Now the session is by Andreas. He will talk about this image builder. Andreas, the stage is yours.
Okay, thank you. Thank you very much. Thank you for coming. This talk is about disk image builder and creating operating system images with this tool. Before defining what an operating system image is, let's have a spot. Let's have a spot to the history. Whoops, sorry, that was too much. Once upon a time, operating system images looked like this. Anybody, any idea what it is? Yes, exactly, from Commodore 64, about 30 years old. So this type of data is something like I want to talk about. So this was about 8 kilobytes, and typically these days the modern operating systems are much bigger and stored on disk. But in principle, it's the same data. 2 sentences about me. So I'm currently involved in mostly 3 projects. The latest project is my do-it-yourself CNC router, which I built these little wooden things there. It turned out that this is mostly a software project I never thought about, but most of the time you sit in front of the computer and try to do the cut and the comp and get things correct. Then I have the RM2. It's an open source requirements management project which I'm working on, and since about a year I'm core developer for OpenStack Disk Image Builder, and this is why I'm here today. My agenda. So I hope I will finish in about 30 minutes. This is really an introduction talk to Disk Image Builder. So it's only, I picked only 2 things out which I want to explain a little bit deeper, but it's mostly really introduction of what you can do with it. So the green lines, it's really introduction, and then these things are a little bit detailed, a little bit more detailed. Oops, sorry, I have to. So an operating system image is mostly something like an operating system in one format, maybe as stored on disk, as an image, which means as a file somewhere on a disk. Other names are also golden images and template OS images, and typically they are used in environments like cloud images or virtualization platforms. This is one way to build operating system images, which means put an USB stick or something like this DVD into your computer, boot it, and you will get sooner or later something like a picture like this, and you have to go through the whole setup of installation and image. You have to specify which packages you have to install and so on. I think everybody knows how to, and mostly did it already, I think, or? Yes. So this is typically a way, if you get a new computer, you put this. Then there is another way. This is using a tool which builds you an image. So there are typically for each operating system, there comes a tool with you which just puts up an operating system on the disk, mostly as a tree structure. There's a example for that bootstrap. So you just enter this thing with that bootstrap stretch and dot, and then you have, I don't know, 2 minutes, 3 minutes later, you have a complete Debian system on your in your directory. So these are the, let me say, the historical things. The problem with this is, for each operating system, something like this, for each operating system, you need a special tool, you need a special configuration, and what you end up, so if you need a couple of them, you end up simply something like this. For all of your environments, for all different operating system distributions, architectures, you have one configuration file, one tool, and then you run it and create something like a disk image. And Disk Image Builder tries to solve this problem. It is something like it takes up only one configuration and builds really a couple of things, a couple of architectures, a couple of target systems from one configuration on one host system. Here are some examples that you can get a feeling for this. So you can just have, for example, to install a Debian minimal system, a Debian minimal or Fedora minimal, CentOS minimal, and so on. And also what you can do is not only creating virtual machines, but also Docker images from it. What is under the hood is something like really the system image, the system tools for this specific operating system are really used. So RPM or apt or dpkg or something like this. So this is done inside. But you as a user of Disk Image Builder, you don't even see this. The support matrix of this, so it's really astonishing how much you can build. So you can build mostly all the mainline things, and you can even build different architectures. And this is really done, really you can cross do it. So you can have, for example, one AMD 64 and build something like for a PowerPC, an image from PowerPC. Or you can have an Ubuntu and then you can generate an OpenSUSE for it. So it's really universal, and yes, you see the bubble over there. This is something like under the hood. So under the hood, it's something, it uses QEMU to run the target operating, so the post scripts, the binaries on the host system, which gives you a really complete, for example, complete installed binaries. Here are some environments. So this is which I've really tested. So VMware, OpenStack, KVM, Amazon, Docker. This is what I tested. There are also possibilities really to use it as a bare metal. So you can use these images, create these images, and then put it with some specific method on a bare metal, and can also use this, this one image or this one based on this one configuration you provide. The Disk Image Builder itself, it's something like a modular system. So what it has is something like elements, and for each function or each function block is put into one element. For example, this Debian minimal is one element, VM is one element, Puppet Master is one element. You can think about hundreds which come directly with Disk Image Builder. And there are a lot of these elements also in the internet. So for example, if you want to install an image for a Raspberry Pi, you can grab it from the internet, specify Raspberry Pi, and you add an image for the Raspberry Pi. Some example elements, so really a small set of examples. Yes, you can see, so I don't want to go into detail here. So there are a lot of things you can just put into your VM directly during creation. Some words, what is an element? So an element is mostly something like configuration, so a set of, let me start in this way. It resists in one directory, and it's a collection of configuration files and directories. And in this directory, there live some scripts. So I have here an example, or a very small example. An element itself can be dependent on other elements. So you can just have a small text file where you can all list the other elements which are also then included. The package installed, so these are the packages which are installed during the creation of the operating system image. And as you see, you can just put the name here, and also you can have something like different ways of specifying names. So for example, there's also some way for different distributions, because the distribution typically name their packages in a different way. Then there is typically some, so there are at least, let me say, there are about 6-7 stages during this build process. For example, you just prepare things, then they are installed, then the bootloader is installed, then the cleanup is run, and so on. So there are 7 different stages of this, and each of these stages are put into a separate directory, and the scripts in this directory are then executed at the appropriate stages. So for example, in the environment, you can set some names which are then picked up by other elements, or in the in the directories themselves, there are something like scripts like these things. So this is really the where all the work happens. Okay, then I want to talk a little bit about the block device layer, because this is an important point. So there are a lot. There are a lot of things you have to really put into the operating system directly. So, for example, adding a package that can be done later with the configuration management system, so in a golden image. But you won't want to, for example, to play around with your partition table, with your LVM and so on later on. So this is something like you have to do first, directly in the operating system during the build of the image. 1 year or something like this ago, the complete block device layer was about, it exists exactly one image and with one partition, and that's all. And yes, there was a lot of work done during this last year to implement different ways. So what we did is something like we leveled, we did some levels. So we have something like, for example, one level in this block device layer inside the disk image builder, which provides disk space. The typical way is to have a loop device, so which provides local disk, but other things are possible which are not yet installed. Then there is a way, the level 1 thing, this is where mostly the complete work is done. So this is something like mostly combining things, what you get from here. So for example, you have 2 loop devices. You can put in one partition table, on the other an LVM, and whatsoever. You can think everything or what you want. And what is important, you can put it this level really into itself. So what you can do is, for example, you can have a partition, and on top of the partition you can have an LVM, based on this LVM you can have, for example, a crypt setup, and so on and so on. Where I can say that the crypt setup is currently not implemented. So you get something like a stack. Yes, the other ways are mostly something like, okay. The other ways are mostly something like, yes, typically what needs to be done. So you need to do a file system on this. It needs to be mounted. It needs, and the FOSDEM handling, because we have to, of course, pass this over to the real system. One example that you can maybe have a think how this is configured. So the complete configuration is done by means of a YAML file. It's one YAML file where you can describe the complete hierarchy for the block device layer. And here's one thing. I think it's mostly self-explaining. So you have a local loop there, which is yes, dev loop device handling. Inside this, there is a partitioning done. Inside the partitioning is done with the master boot record. And yes, there is, for example, one partition, which is primary, and so on, and the whole thing is done. So this is really a very, very simple example to get you an impression. So typically, if you have something like logical volume inside the partition table, and you have 5 or 6 logical volumes. This gets really lengthy. But so everything is possible here. This is just an impression to give you an idea what happens. Okay. Yes. Then there was a time where it comes to this writing this MBR, this master boot record. These are 72 bytes, which has to be at the correct position. So I did a DD there, that you have something like so most of them are also zeros. And of course, the typical way is look at the internet, grab something which is available and use it. And we discussed it really on the development side, and we really didn't find anything which we can use, because all these tools are either not really thought for scripting, or they're doing a lot of things they shouldn't. For example, we had to look at this parted. So this is the GNU parted thing. One clash, but we could around this. It was license, because this is only GNU. It is really a GPL, not LGPL. So it's a little bit, and the whole disk image builder is under Apache. So we have something like maybe a problem there if we would have used the appropriate libraries there. Calling parted would be possible, but parted itself does a lot of things which, in my opinion, it shouldn't. So it just not only writes these bytes there, but also do something like calls the kernel for updating the partition tables. It calls UDEF. It tries to optimize things. And this is really what comes into mind where we really sorted it out. It tries to optimize things. So it looks, for example, into the kernel, which are the buffer sizes of the disk which I want to create, and tries to optimize, tries to align them. But currently, we are on the host system and targeting for a completely different system. And I have measurements that using parted gave at some point a performance for about only half the performance. So you lose about 30 to 40% performance if you don't align correctly. So this is why we really implemented this thing as in Python in 150 lines of code. So know it there, know it's tested. If you want to write, you will have something like a master boot record, you can pick it there and you can use it. Okay, so then maybe some development insights. This is the OpenStack is an disk image builder is an OpenStack project. It's a part of a project, and it's from the size here. It's really small. So it's about 1,200,000 lines of code, and it's about 7,000 lines Bash and Python mostly. The new block device layer, which was created during the last year, is about 3,000 lines of code. What is a little bit problematic, what I think, is that there are really many adaptations. So let me say something like this. Every third line is something like, if you have this system, we know that there is this problem and we have to work around this. So this is a little bit problematic, but for such a tool which aims to be universal, you have to do something like this, or you cannot just support it. Yes, also the design should be improved. I think we did already do a lot of things there. For example, adding this block device layer, because before it was something like spread around, so each element has an own idea about it, and now it's really centralized, but there are other things which could be optimized. What is sometimes really annoying to me is the slow development cycle. So you have your great idea, put it into Garrett, and nobody cares. So this is really something like really strange. And it takes weeks or months that somebody else picks it up and have a look at it. So this is, I think, in my opinion, I'm not really sure about the other OpenStack projects, but this is for disk image builder, this is really a problem. So we have, I think, one patch outstanding for EFI boot, which is mostly 2 years old now. And yes, it's really hard. So even so, if you have some spare time, you're invited to have a look at this, so everybody can also review it and have their own thought there. And the last thing that is a little bit related to this is that all the different maintainers or the different contributors really focus on their own development. So they just want to, for example, feature X, and they just really try to put it in, and even if it's really not in the right place, if it doesn't really fit into it, even if it's really, sometimes you get something like a mess. So we have just to say no, not this way. Whoops, that was one recap. So as I said in the beginning, this disk image builder, one configuration, all targets. But this is just for an ideal world. As I said, there are a lot of problems. And there is one matrix build. So there's something like an element which in turn builds Docker images, which in turn then use disk image builder to build all the other things. So what you have is something like a building matrix. And you don't have to read all the things, but it's just to give you an impression. On the top, there are the hosts. So it starts with CentOS 7, Debian, Buster, Jessie, Stretch, and so on, Fedora, OpenSUSE. And this is not really finished, so it goes on. And here, there is a target. There's a target, so which ones you try to build. And I do this each some weeks to get an impression how stable it is and how where is some work. As you see, there are a lot of greens, so there are a lot of things you can really build, but you have really to take care that some just do not work. So, for example, there are some problems like it's not here, but for example, OpenSUSE. Just to pick one example, there is something like that. There are some no scripts, for example, to build up-to-date Debian systems. So you just cannot do this because they're just missing something. Yes?
But the problem, second, fourth, 5, and 6, the missing script,
yes,
is usually you just need to do a symlink because
yes,
the bootstrap is using the same file for basically every distribution now. And it just one symlink, you run as root anyway.
I just repeat what you said to get. So you said that for 2, 4, 5, and 6, there is only the need to create a soft link to some other already existing version. Yes, you're right. I have no idea why this is done in this way. The problem is that let me say you as a user just picks the things and wants to execute the program. You can just disk image builder. You can just install on mostly every distribution, and you don't want to get root and try to get rid of or add some new symlinks. Okay, some advantages is speed. So if you have really set up a good environment, for example, having a HTTP cache or package cache, RPM, Debian cache, the complete build of an operating system image is done typically in 2 to 3 minutes if you don't have something like a big thing. So if you concentrate on the minimal things. You have one configuration for all targets. And as I said, it supports many, many distributions, architectures, and host and target systems. The next one, it's really something like, is as seen, that only a limited set of functions it's testing during the CI itself. So the CI in Gerrit, in OpenStack, it's Zool, and it's mostly, I think, all things are run on the up-to-date Ubuntu version and an up-to-date Fedora version, and that's mostly all. The rest, it's something like not really tested during the CI process itself. And what is also a disadvantage is that, at least currently, so you can build Docker images with this, but it's not really optimized for it. So when you get images, you can use as Docker images, but they are in size not really comparable to something like a minimal system. So there are a lot of packages installed which can be removed there. So there has to be some work to do. Sorry. Yes, this I want to really to emphasize. So what to put into a system and what not. This is a little bit of learning of the last some years from my side. And the thing is, be as general and minimal as possible and for the system. Don't install something like applications which you just need in 10% of your machines. That's not needed. Of course, what you want is you have to install for example, hardware-dependent things, so hardware drivers or so, which are needed to build to boot the system. But be as really minimal as possible. The second point is, yes, I learned it on the hard way, let me say. So don't do hardening this early. The hardening it's a steady process. So hardening should be done later on, because typically what you do is you have something like a general image and you don't know what you install later on in this. For example, you have an image and later on you add, for example, a Postgres database in it. Where you want to harden it. So if you have the image hardened, the Postgres isn't hardened. And also, yes, you have to really to see what you want to do with this, yes, and when you have to do this hardening. So the best practice I see is that you have something like Puppet or a Chef or whatsoever configuration management system provided by security, or there are also some projects in the internet, and they should run, don't know, each day. Because, for example, if you update a package, the hardening may be overwritten. And the latest point is what I already said. Do the disk layout during operation image build directly. Okay, so this is a general rule of thumb to things as late as possible. Okay, that's from my side. I think I'm time. We have about 10 minutes question and answers time. So if you have questions, yes?
Yeah. Do you have anything going on for set-up file system support in the images?
Sorry, I didn't get this. Did you?
Do you have plans for supporting CFS, ZFS, in the good images?
Okay. The question is if there is a plan to have CFS in the file system. Currently, there is no such a plan.
Not CEF.
It's not CEF. CFS.
File system.
Sorry, CFS. No, also no ideas. Sorry.
What?
Yes, please.
What is the main difference of your project compared to, say, Hacker, which also creates images from a description? Doesn't it?
I don't know this project. So the question was, what's the difference between this project and other projects like Packer? And I cannot say that much to it because I have no idea about Packer, so it's hard to say. Yes, please.
You told that there are many pages rotting basically in Gary. How many core developers are in project?
We are currently, let me say, 2.5. So there is one guy called Ian. He's sitting in Australia, so it's a little bit hard to synchronize. And there is one additional woman, which is something like she seldom really writes something, but she's trying to test things. So this is something like yes, we are only 2, 3, which is not that much. Yes, please.
Is this image builder available in Fedora, Debian, and so on, or is this an internal tool for OpenStack? What's the target audience?
The target is so the question is, what is the target from OpenStack? Is this only for OpenStack? The target from Disk Image Builder, is it only OpenStack, or are there only? Can you use it as Fedora or Debian, something like this? Disk Image Builder is rolled out with OpenStack, but you can install it on mostly any distribution. So, for example, if Ubuntu and Debian have their own packages, you can just apt-get install. I'm not really sure about Fedora, but what you can do is it's also available with PyPy, so you can just use pip, install Disk Image Builder, and you have it, and you can use it. It's about 2 minutes. Yes, please.
Do you also provide the Disk Image Builder as an element for Disk Image Builder?
There is an outstanding patch. Yes, exactly. So this was my idea. I created this patch to have exactly this, to have inside Disk Image Builder an element you can just build, and we have a test or development for Disk Image Builder. Yes, please. Sorry, I didn't get this.
If there are any elements that you can use and you can create an image directly for mining, like you have for the Raspberry or you have the Puppet Master data mining.
No, this is the question was: is there some ready-to-use element for data mining? Is it correctly?
Yeah. For example, you need to install Linux and then you need also to build the miner. Yeah. So like you have the Puppet Master, so this is an element you can use to create images with the miner also.
What is there? There's a Puppet. When I get your question correct, there's a Puppet Master element for this one.
Yes. For example, Puppet Master element. What does it do? When I install the image.
Yes, it's installed in complete Puppet Master. It installs the complete Puppet Master then.
Okay.
Yes.
So there is nothing that will install a complete miner, so you can do that a miner.
No, it's not. Yes, please. Jetzt ist hier. The question is, what about GPT, the partition table you think about? There's really ongoing a patch, which is, I hope, something like maybe next or maybe in 2 weeks it's there and will be in the next release. I'm not really sure if we have some time, if there's some time for more questions. Maybe you at the top.
I have a question about the installation process. With Packer, the target machine is emulated like you build for VirtualBox or for KVM. And spinning up the VM with the hypervisor and setting up a block device. But you have to say, like, I need to install 20 gigabytes of this. Later on in the post-process, you have to shrink this device for faster processing, like transferring the image to the actual cluster used to simulate or emulate target platform or device? Or it's just like the Debian only use debootstrap for that? So the debootstrap you just install in your directory and not
Okay, okay. Okay, when I understood it correctly, it's something like how does a disk image builder uses the different ways of storing images, like a raw image, or what? So okay, there are currently, so internally it works in a raw. So it has a dupe device, it has a raw image, and after the process, it automatically converts it to something you give at the command line. So typically you have something like QCOW, BMDK, tar, whatsoever, what you want.
everything is handled locally, not in a virtual environment?
Exactly, everything is handled locally.
Okay.
Yes. Yes, on the top?
Why did you decide to implement the block layer itself and not take something existing? I'm thinking of Git, which is on corporate embedded, which does TCP and just tries to partition the disk in a file and tie them all together. I guess there are other tools around.
The idea, the question was, why does Disk Image Builder not pick up something like an existing project for describing the partitioning the block device itself, correctly? Open speaking, I didn't find something. So if you can point me to something, I'm really happy. This was also really my first touch with Disk Image Builder. I looked through the internet exactly for finding something which gave me the whole bunch of things yes, which can be done with Disk Image Builder now, but I didn't find anything. So this was one reason to put it there. Okay? Please.
What about GPT partitioning?
Oh, we had this question already. It's about GPT partitioning. There is currently really a patch outstanding, and there is a lot of work done on this, and I hope it's maybe merged next week or so. Okay? Any questions? Okay?
You recommended against doing partitioning yourself. Why is that?
The question is that why I recommend against partitioning.
Yeah, doing it outside of the Disk Image Builder.
No, it's not outside the Disk Image Builder.
But I'm doing it outside. Is it bad, or why isn't it not recommended to do it like that?
Sorry, I didn't get.
Was we should do the partitioning and GPT or MBR within the image.
Yes, because it's something like very basic for the image, and you won't want to change these things later on. So for example, I have something like a problem with it doing and setting up an LVM with Puppet. So maybe it's possible, but from my opinion, this is not really the correct time. So do things. I'm not really sure if it's.
Well,
if I get you.
When I'm writing the image, I'm setting up the partitioning and then I'm writing the image into a partition, not to the entire disk with partitions.
Yes, yes, you can do this also. So you can do this something like a partitionless thing. So you can just use an image, a raw image. Right. This is also possible, and then you can just put it into an image. Yes. One question or not? Okay, time is up. Thank you very much.